The easiest type of stoichiometry is mole-to-mole stoichiometry. This is a one-step process if we have a balanced chemical equation. To execute a mole-to-mole stoichiometry problem, we multiply the given chemical mole amount by the appropriate mole ratio. Remember that the given chemical will be in the denominator of the mole ratio with the coefficient from the balanced chemical equation. The desired chemical will be in the numerator of the mole ratio with the coefficient from the balanced chemical equation. Let's look at worked example 6.5. Rusting involves the reaction of iron with oxygen to form iron 3 oxide, capital F lowercase e subscript 2, capital O subscript 3. The balanced chemical equation is given as coefficient of 4, capital F lowercase e parentheses S end of parentheses, or 4 moles of solid iron, plus coefficient 3, capital O subscript 2 parentheses G end of parentheses, or 3 moles of gaseous oxygen, arrow, or yields, coefficient 2, capital F lowercase e subscript 2, capital O subscript 3 parentheses S end of parentheses, or 2 moles of solid iron 3 oxide. Part A asks us what are the mole ratios of the products to each reactant and the reactants to each other. Part B asks how many moles of iron 3 oxide are formed from the complete oxidation of 6.2 moles of iron. We'll look at Part A in more detail in another video. Since Part B is mole-to-mole stoichiometry, let's start with it. Part B asks us to determine how many moles of iron 3 oxide are formed by the complete oxidation of 6.2 moles of iron. We know this is a stoichiometry problem because we are given an amount of one chemical, 6.2 moles of iron, and asked to find the amount of a different chemical, moles of iron 3 oxide. When both amounts are moles, this is known as mole-to-mole stoichiometry, and all we do is multiply by the correct mole ratio. Remember that the mole ratio has the given chemical in the denominator and the desired chemical in the numerator. Since we are given an amount of iron, or capital F lowercase e, iron is in our denominator. The chemical we want, iron 3 oxide, or capital F lowercase e subscript 2, capital O subscript 3, goes in the numerator. We obtain the coefficients from the balanced chemical equation, so the correct mole ratio is 2 moles of iron 3 oxide over 4 moles of iron. You can reduce this fraction to lowest terms if you like, but you certainly do not have to. Your calculator can handle it. To get our answer, we multiply the given value of 6.2 moles of iron by the mole ratio of 2 moles of iron 3 oxide to 4 moles of iron. Moles of iron divided by moles of iron cancel out. 6.2 times 2 is 12.4, divided by 4 is 3.1. Our answer is 3.1 moles of iron 3 oxide is formed when 6.2 moles of iron react. Does our answer make sense? If we look at the coefficients from the balanced chemical equation, we see that the ratio of iron to iron 3 oxide is 4 to 2, or 2 to 1. There will always be half as many moles formed of iron 3 oxide as the moles of iron that react. 3.1 is half of 6.2, so our answer makes sense.